Hey there, welcome back. So, this is the end of the assembly programming course. So, today we have a lot to talk about, so let's just get started.
Okay, so the final act. So today we are not going to be learning anything new, any new mnemonics or any new assembly specific things. Now we are going to look at how we can apply the things we've learned to our projects in NESmaker. So we have quite a few things to look at today. Um, I'm not going to be reading everything right now, but if you pause the video, you can see what we're going to be looking at today. So basically, we're going to look at where you can find the different things in NESmaker. For example, if you want to do something that has to do with gravity, for example, or hurting the player, or something that has to do with tiles, if you want to make your own tile or whatever. So we're going to look at a lot of things like that today and where you can find different things. But we're also going to be quickly talking about bank switching. Now, bank switching, that's a very big topic, so we're going to just briefly look at it today. And we're going to be looking at an example game that I made. Now, I made two different versions of this game. The first game is stock NESmaker, meaning I did not modify anything. So it's made with stock NESmaker, and then there's another version where I've modified quite a few things to improve the game. So we're gonna take a look at that and compare those two to see why we would want to do some custom assembly programming. But let's just start with bank switching. Like I said, we're just gonna briefly talk about this today. So you remember the NES cartridge that we talked about a while back. So when you plug the cartridge into your NES, now we're talking about the stock, the first NES cartridges, the black box games. Those had 40 kilobytes. So they had 8 kilobytes of graphics, 32 kilobytes of code. So 40 kilobytes in total. And if we look at the memory that the 6502 CPU can access, it can only access 64 kilobytes of memory. That's the maximum memory it can see at any given time. So when we put the 8 kilobytes of graphics in here and the 32 kilobytes of code in here, there's not a whole lot left here. So the old cartridges were 40 kilobytes. Now the NESmaker cartridges are 512 kilobytes. So those are over 10 times the size of the old black box games. Now, how does that work when we can only access 64 kilobytes at any given time? Well, of course, that's where bank switching comes in. So, like I said, let's just quickly take a look at the concept of how that works. And like I said last time, don't study the memory addresses here because they're probably not correct. I'm just trying to show you the concept of how this works. So when you plug in a cartridge, something goes here and something goes there in the memory of the NES. So this is the black box game. 8 kilobytes of graphics, 32 kilobytes of code. What about these bank switching cartridges? Well, here we go with the NESmaker cartridge. So it's 512 kilobytes in size. And the way it's set up is that it has a lot of these small banks in here. Each of these banks is 16 kilobytes. So you have a lot of these 16 kilobytes banks inside the cartridge. So instead of just having this 32 kilobyte thing that we plug into the memory, we're still plugging in 32 kilobytes at that area in memory. But if you look at how this is set up, we have 16 kilobytes of something here, 16 kilobytes of something here. Now, if you've been programming in assembly language using NESmaker for a while, you probably heard about this bank 1F and how important that is. Bank 1F, that's sacred almost. Why is that? Why is bank 1F so important? Well, it's because bank 1F, that's always banked in. Meaning, when you plug in the cartridge, bank 1F, the code, whatever's in bank 1F, that's always banked in at this part of the memory. Meaning, if you have a subroutine or whatever in bank 1F, you can always call that subroutine. You don't have to worry about bank switching or anything like that. It's always banked in. Now this other bank here that I've called switchable bank, which is also 16 kilobytes. Now that part will change. So that's where this bank switching comes in. Right now we have this little bank switched in. So right now the NES, if the NES looks at the memory, it can see whatever is inside this little bank. So in here we can have, let's say it's a routine to hurt the player, hurt the monster, stuff like that. So right now, if we're here in bank 1F, we can say jump to subroutine, hurt player. All right, no problem. Let's just say that hurt player, that was a subroutine at memory address 9000. So somewhere around here. So okay, that's no problem. We run hurt player, go here, run that, no problem. But now I changed the bank to this, another bank. So now this part is switched in here. So meaning that whatever code is in this bank, now that's visible at that area. So if I try to run hurt player now from bank 1F, hurt player, now I try to run a subroutine here at memory address 9000 because I am expecting hurt player to be there, but it's not there. The hurt player code is not in this bank. So if I try to run hurt player now, when this bank is switched in, there's going to be something completely different at that position now, because this is a different bank. Let's say that this bank handles tile collision, stuff like that. So at memory address 9000, I don't have a hurt player subroutine anymore. Now maybe address 9000 is in the middle of a huge table or something like that. So when I try to run hurt player now, I'm just running some random code. And in most cases, that's going to crash your game. So if I want to run the hurt player subroutine, which was in the other bank, then I have to bank switch back to that bank. So when this bank is switched in, now I can run the hurt player subroutine, because now that bank is switched in. But when I switch to a different bank, now there's something completely different in here. So it's very tricky to keep track of all these things, and it's definitely not something that's beginner friendly. This really takes a lot of practice. First of all, to understand the concept of bank switching, to understand that there's something different at the same memory area based on what bank is switched in. And you can't run a subroutine that's located in a different bank. If you can't run a subroutine in this bank if this other bank is switched in. So there's a lot to think about. So we have all these different banks that can be switched in, but bank 1F, that's always banked in. So like I said, this is just the concept of how bank switching works. And we're not going to go into detail today because we have a lot of other stuff to talk about. But I just wanted you to show you the concept of how this bank switching really works. So bank 1F, that's a really important one. And whenever you're in bank 1F, you don't have to worry about bank switching. Right, so now let's look at the example game. So, first of all, let's just look at this stock game that I made, meaning the version I made with stock NESmaker. So I'm just gonna run this game right now. And let's see what it looks like. So here we have Super Game. I made this start screen here. Now look at this. Already here at the first screen I have a little annoying issue. Now it's not anything game breaking of course, but this is not great. What is this stuff? Well, now I'm using stock NESmaker, haven't modified anything. So what we're seeing right here, that's the Sprite Hud. So this is where during normal gameplay you would see something like your health, stuff like that. Now of course I don't want that on my start screen, but if I don't modify anything, it's there by default in stock NESmaker. Alright, so I'm gonna start the game now. And here we go, with my player. I can shoot this monster, but I shot something, but I just dropped these things. Now that's because by default NESmaker is set up with 5. The my ammo variable is set up with 5. So you're basically starting your game with 5 my ammo, whatever your ammo thing is. So now that I've used all that ammo, now I can shoot normal stuff. Okay, so we have a lot of stuff going on here. So, but there we go. So now I'm shooting normal bullets. And I shot a few bullets and now I can't shoot anymore. Well, that's another issue that we're gonna have to look at. The problem is that when the bullets go off screen, they don't really disappear. They linger on there at the edge. So I'm just gonna keep scrolling, and now they're gone. So now I can shoot again. And there's another issue we have to look at, and that's the Sprite HUD up here. So now I'm just gonna go in here, and I'm gonna go up this ladder, and now finally I'm gonna shoot this monster. Okay, so I shot the monster and it just disappeared. So, shot the monster and it just disappeared like that. I want something a little more interesting for my game, so we need to do something about that as well. Now, there's another thing here. Now I'm going to... Alright, so now let me just scroll the screen. And there I got hurt. So now in stock NESmaker, if I get hurt, the player gets pushed to the side. Now the screen doesn't scroll along with that. So now I ended up here at the very edge of the screen, which is going to give me a few problems. So we need to take a look at that as well. So there are quite a few things here that we need to address. So it's not too bad, I guess. We do have a game here and we can shoot enemies and stuff like that, but there are quite a few issues that we need to deal with. So that was the stock game. Now I'm going to show you the modified game, where I've modified some code, added some new code, and improved the game in several ways. So let's take a look at that, see what that looks like. So here we go with the modified game. So the first thing we see is that we can see that we don't have this sprite HUD anymore. I made sure that the sprite HUD is not visible on the start screen. So I start the game, and I've, as you can see in the top left corner up here, I've set up the sprite HUD in a more interesting way. Now what happens if I shoot this skeleton? Now he sort of explodes, which in my opinion at least is a little more interesting. Now if I get hurt now, you can see that while I have this player recoil, while I'm being pushed back, I have this knockback. I'm flying back, but the screen is following along, so I don't end up at the very edge of the screen. So let's see here, and now I have some ammo. I have some random drops from the enemies, so I have a lot of stuff going on. I landed on some spikes, and I got the player death animation and stuff like that. So let's just keep going here, and let's just see what else we have going on here. So I've made this lock tile, a locked door. Now I can't go in there, but if I go here and I pick up this key up here, and then I go back and I go down here, now I can open the door, go down here, I pick up this heart, and now I have increased my maximum health, and now I can just continue on here. So I've also added a tutorial that I've added on the NESmaker forum quite recently, where the player does not wiggle on the ladder if you let go. So if you hold up or down, you can see that he's animating, but if I let go of the control, the animation stops. We're not going to be looking at that today, but I just wanted to show you. So as you can see, in my personal opinion, we have improved the game here in several ways. So you have to look at what I actually did to improve all of these things. Now it's important to remember that what I'm going to show you is applies mostly in this case to the Metrovania module. Now a lot of things are similar or identical in other modules, but I'm just going to use the Metrovania as an example today. So let's just go to the project settings up here. Now the project settings, that's where you'll find a lot of interesting things, variables, constants, whatever. But right now we're going to use script settings. Now here in script settings, what we actually have here is a lot of assembly scripts. If you remember back to the beginning of this course, I talked about all these scripts being put together and create a huge assembly file, which in the end will turn out to be our game. Well, these are a lot of those assembly files. Now up here we have what we were talking about earlier in this video. We have a lot of these banks. So a lot of different banks and whatever code are in those different banks. Now, let's not look at that right now because that's a lot to look at. But what I wanted to show you here is something down here under game. So here under game we have something called Initialize. Now, in the initialization script, that's something that sort of runs before your game starts in a way. So it's actually what it sounds like. It initializes your game. So let's just take a quick look at initialization. So I'm going to edit that one. So there's a lot of stuff going on in here, but I wanted to show you one interesting thing. If I scroll down here in the initialization script, you can see something here. We're creating an object inside the initialization script. What object is that? Well, here we're actually creating the player object. We are creating object 0, the player object. So this is where the player object is first created. And right after the player object is created, we make sure that we set that object to the variable player1 object, we set it to the cam object, and we set the object screen and so on. Now I've added something else to the initialization script here. I've said that I want my player to start facing right, because by default in NESmaker there's nothing in here. So if you have a game where you shoot, a Metrovania game where you shoot, if you don't have this and you don't touch left or right or anything on the control, you just start your game by shooting, your bullet won't go left or right or anything like that. It won't go anywhere because the player does not have a facing direction. So that's why I added face right to the object direction here in the initialization script, so that now when I start my game, I can just push the shoot button and I'm going to shoot right. So it's just a little detail, but I like to add stuff like that to polish my game. So yeah, we have a few other things here in the initialization script. Let's not spend too much time in here. But I thought it was interesting to show you that this is where the player object is actually created. Right, so the other thing I wanted to show you, or the next thing I wanted to show you, that's the scrolling itself in the Metrovania module. Now by default, let's look at the stock game here. This is stock NESmaker. So if I go to script settings here in stock NESmaker, remember this is the Metrovania module. So the thing that handles scrolling here is the default script called do update camera. Now as we saw in the game, it works, the game scrolls, so it does work, but it has a few issues. Some of the issues we already saw, which is if you're hurt, your player gets pushed to the side, and there are a few other issues. So a few years ago, a NESmaker forum user called Sinestist made something amazing. He made a completely new handle camera script. So if you go back to the modified game here, so this is the modified game. If I go down to handle camera now, you can see that I'm not using the do update camera. I'm not using the default script for scrolling. Here I'm using new camera handler, which is the one that Sinestist made. So this is a fantastic script. It improves the default scrolling script in many ways. In fact, it actually adds features as well. Like for example, you can see here auto scrolling. So that's very cool. And basically the new camera handler, that script makes sure that the camera is following the player. So even if you're hurt, even if you're not holding left on the D-pad to walk right, even if it's just thrown back because you're hurt, even then the camera will follow you, or the scrolling will follow you. So this is a great script by Sinestist. So by the way, I'm going to leave a lot of links in the description for this video, and of course this will be one of them. So we have so much to talk about that I'm not going to be going into detail for every single thing. Now I'm just going to give you sort of an overview of where you can find the different things. So we looked at the initialization, we looked at scrolling here in the Metrovania module, and now let's look at the input scripts. Now, of course, input scripts, that's some default NESmaker thing, and if you watched the official tutorials, you probably know how to set up input scripts. But I made something that I called simplified input scripts, which are these input scripts: move left, move right, stop moving, and jump through plat. Now, let's go back to the stock NESmaker game. If we look at the let's go to input editor here. This is how you set up input scripts for the Metrovania module in stock NESmaker. So the way you're supposed to do it is that if you press in the direction, you run this script, change action to moving. Now if you hold right, then you're actually going to move the character right. And also if you hold right in the Metrovania module, you're going to run this script called do simple scroll right. So you have 3 scripts for moving right. Also, when you let go of right, release right, you change action to stop, you stop moving the player, and you also stop the scrolling. So we have 6 scripts here for moving right, moving on right and stopping. Same thing for left. So first of all, that's a lot of stuff to keep track of. But another thing, if we go back to the improved or the modified game here, let's look at my input editor here. Now here I'm using the simplified input scripts. So if we look at this, here I say hold right, and I'm using my new input script called move right with action. So I'll just say hold right, move right, release right, stop moving. So I just have 2 scripts here for moving right and stopping. Same thing for left, hold left, move left with action, release left, stop moving. So it's a lot less to keep track of, and these simplified input scripts work great with Sinestist's new camera handler. So for example, if you're using the new camera handler and the simplified input scripts, and you hold right, your player is moving right, but then he gets hurt. He hits a monster and he gets hurt. He gets some knockback, goes into action step 7, the hurt animation, and he gets pushed back. But you, as a player, you never released right. You just kept holding right. So your player walked right, he got knockback, and you're still holding right. If you're using this setup, when your player goes out of his hurt animation and back to his normal self, then it's going to go back to keep walking. So you're walking, get hurt, and you just keep walking. If you do this in stock NESmaker, the same scenario. You're holding right, you hit a monster, you get pushed back, knocked back, and you never released right on the D-pad. You're still holding right on the D-pad. When you go out of the hurt animation and you're still holding right, your player is just going to move right. He's not going to go back to his walking animation. And that's because of the way this is set up. Here in stock NESmaker, you have to press right to change action step to moving. So you have to actually press right for your player to go into his walk animation. Now in the modified version here, you don't have to do that. If you just hold right, then your player is going to go into his walk animation as long as he's moving right. So again, I don't want to get too much into detail here, but just to show you that using new camera handler and the simplified input scripts, just using those two things, you can improve a lot of issues that you might have with the stock NESmaker. Yeah, let's just continue on here because we have a lot more to talk about. So there's another thing, and this is a really annoying issue, and I've had this issue ever since NESmaker 4.5.9 was released over 5 years ago. So the issue here in stock NESmaker is that let's see if we can get it to happen here. So this is a problem that I call hit out of nowhere, which basically means that you can be walking along, just walking along here, avoiding the monsters. Let's see. Okay, so what the problem really is that you can get hurt without actually colliding with the monster. So it didn't happen right now, but it's a very common issue. To fix that, I worked for such a long time to fix that. I could not figure it out, but ClockFox on the NESmaker forum actually solved this for us. So if I go back to the modified NESmaker now, and I go to project settings, script settings. This is the modified version of the game. If I go all the way down to subroutines, down here there's something called compare object boxes. This is the script that compares the bounding boxes for your player, for your monster weapon, and so on. So what ClockFox did was he modified this script. Again, I'm going to leave the link for this for the post on the forum in the description. But by replacing the compare bounding boxes script, this issue almost went away completely. Now I have had a few issues where it still happens, but it's basically a non-issue when you replace the code for the compare bounding boxes. So that's another thing that's really important to do if you're making a Metroidvania game, to fix that bounding box issue, so your player won't get hurt out of nowhere. Yeah, I just wanted to show you where you can find it, and then I'll leave the link in the description. So now let's look at another thing, a thing that's closely connected to this. Object collisions. Now I've made a few videos about object collisions, so I'm not going to talk too much about this, but right here we have something called handle object collisions. Now this script is the one that checks what object collided with what other object. So if I click edit on this one, now this is the modified game. So here in the handle object collisions, we're basically checking collisions for two things: the player weapon and the player. So we're not checking collisions for if the monster is walking around. We're not checking, did the monster collide with a power-up, or did the monster do this or that. We're just doing those checks for the player weapon and the player himself. Now, that of course means that we are checking if a player and a monster collides, but we're checking that from the player's side. We're checking, did the player collide with the monster? So that's the sort of thing that happens here in the handle object collision script. And if we start here at the top, because we're starting by checking the player weapon. Did the player weapon collide with anything? So is this a player weapon? Yes, it is. Okay, did the player weapon collide with a monster? Yes, it did. Okay, then we run the do handle monster script, which is something we're going to look at in just a second. So the handle object collision script is really important if you want to add custom collisions or if you want some custom thing to happen when objects collide. Like I said, I have made a few videos about this, so I'm not going to be going into any detail here. But I just wanted to show you where you can find the script that handles object collisions. Okay, so we talked about hurt monster. So if we go up a little bit here in script settings, under common here, we have a script for handle player hurt, handle monster hurt. So we have those two scripts. Now, if I go to stock NESmaker now, if I go to stock NESmaker project settings, and now I go down to common and handle player hurt, for example. There are a few things that you might want to modify here as well in the stock player hurt script. For example, if the player health is 0. Now this is the Metrovania module. When the player health is 0, basically you're resetting the health and you're warping to a screen here. I find it more interesting if the player has some sort of player death animation. And you could do that in several ways. You could make an action step for your player death animation, or you could have a separate game object for the player death animation. So this is where you would handle that. But there's if you look at the monster hurt script here, monster hurt script. Now this script is something that you definitely would want to modify, because here we're just destroying the monster when you shoot it. Just goes away like that. Like I said, for me at least personally, I would like some sort of monster death animation. And the way I do that is just by having a monster death object, which just has, let's look at the modified game. If I go to game objects, I have a game object here called monster death. It just has this animation. And the only thing this monster death object does, it just plays that animation at a fast animation speed, and at the end of the animation I said destroy me. So if we look at in this modified game, if I look at project settings, script settings, handle monster hurt for the modified game, here you can see how I did that. So here I say I subtract health from the monster. The monster health is 0, so now I want to destroy it. What I do here is I get the X the X position of the monster, I store that in temp A. I get the Y position on the monster, store that in temp B. I get the object screen, whatever screen the monster is on, store that in temp C. So I have stored exactly where the monster was. Then I destroy it. Now, after having done that, now I create this new monster death object at the exact position where the monster was. Also, let's just notice that when I create objects like this, I usually do this: TXA, PHA, PLA, TAX. Now, if you follow these videos in this assembly course, you know what that means, right? This is the stack. We're pushing the X register to the stack. Then we create a new object. After that, we're getting the X register back from the stack. Meaning that we make sure that the value in X is the same when we're done creating this object as it was up here. Because when you create a new object, you change the value in X. So that's why it's important to do this, to make sure that we don't corrupt whatever's in X. Yeah, so that was the monster's health. But let's look at here in the modified game. Let's look at the player hurt script, the modified player hurt script. Here you can see that it just says player hurt here. Well, I've taken the player hurt code completely out of this script, and I made a separate one. Player hurt. Now this is a little confusing, and I could have done it in a better way, but I made a separate player hurt script here, or a player hurt subroutine. Here's the player hurt subroutine. Now this subroutine does a lot of the same things like stock NESmaker. We decrease health, we change the if the player gets hurt, he goes into action step 7, and so on. And he has a recoil and stuff like that. And once the player health is 0, then we do some other stuff. We stop player movement, stop scrolling, disable inputs, and then I get the X and Y position of the player and I disable him. And then I create a player death object, very similar to how I did it with the monster death. Okay, so why did I make a separate subroutine for this? Isn't that a bit redundant? Well, here's the thing. The player hurt script, that is being run from bank 1C. Now, player tile, or the tile collision code, that's in bank 18. So player hurt, bank 1C, tile collision, bank 18. What happens if my player, let's say I wanted to hurt the player once he landed on some spikes. Now remember, spikes, this is a tile. So when the player collides with that tile, then we run the tile collision code. Like I said, the tile collision code is in bank 18. I can't run the hurt player script in bank 1C if I'm in bank 18. So what I did here, and this is the reason why I made this separate subroutine, this player hurt subroutine, I put that in bank 1F. That means that if I'm doing the object collision, player collides with a monster or whatever, hurt the player, or if the player collides with a tile, doesn't matter if we're here, if in this bank, or if we're in that bank. we can always run the player hurt script because that's in bank 1F. So now I can hurt the player if he collides with a monster or if he collides with a tile, a hurt tile, because my player hurt script is in bank 1F. Now, just to show you how I did that, just making that player, that custom player hurt script, that's not difficult. I just made, like you saw here, it's just an assembly file, .asm file, where I put the player hurt code. But how does it end up in bank 1F? Well, if we go back to project settings here, there are several ways to do this, but probably the easiest to remember is that if you go here to load subroutines in script settings, load subroutines here, and we edit that one. Whatever you put in here, that's going to end up in bank 1F. So that's why I just put this here at the top of load all subroutines. So now my custom player hurt code is in bank 1F. So I just made something called a script define. If we go back to this custom player hurt thing, you can see that I just made something called player hurt, and the define is just scr player hurt. And after doing that, I just did it the normal way by assigning it, by just double clicking the file here on the right. Once I did that, I made sure that it's in load all subroutines so that it's in bank 1F. Alright, so that's the player hurt. Let's also look at how I set up the Sprite Hud. So I'm gonna go back to script settings now. And now I'm gonna go back to common. And here we have handle drawing Sprite Hud. If I edit that one, first of all, I made sure that the Sprite Hud is only going to be visible at game state 0, and that's main gameplay. So here I'm in the middle of the game, and the game state here is main game. Now game state main game, that's game state 0, 0, 1, 2, 3, and so on. So the Sprite HUD is only going to be visible at this game state. So here I say load A with the variable game state, branch if equal. Now you remember what that means, right? I don't have any compare here. That means that we're comparing with 0. Load A with game state, branch if equal, branch if it's 0. So if the game state is 0, then we do draw Sprite HUD. If the game state is not 0, so for example if it's 1, which is start screen, then we're not going to be drawing the Sprite HUD. So we jump to skip draw Sprite HUD down here. Just skip all the code for the Sprite HUD. So maybe I went a little overboard here with the Sprite HUD because I have a lot of stuff going on here. So when you're making a Sprite HUD, there are several ways to do it, and one sort of very NESmaker specific thing is that we have a macro here called draw Sprite HUD. And what that draw Sprite HUD macro does, it draws something like a life bar, for example, or let's say you have hearts that shows how much health you have. You have 5 hearts. So what this is going to do, the draw Sprite HUD macro is going to draw, if you have 5 hearts, 5 health, it's going to draw 5 hearts. And we put that at this X position and this Y position. Now this X and Y, those are in pixels. So 16 pixels from the left to the right, 18 pixels from the top and down. That's where I want this to start drawing. This next one, that's the I think that's the empty container. So if I have a heart, that shows how much health I have, and if one of those containers is empty, then that's the first sprite. Let me open up the game object tiles here to show you. So when we're talking about these sprite numbers, like 126 for example, it's what sprite we have in here. So starting here at the top left, 0, 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, and then 16, 17, 18. So we have all of these going down here until we get to 127, which is the one at the bottom right corner. So here in my draw sprite HUD macro, I say for the empty health tile, use sprite 126, which is this one, this empty heart. And then what's the max health? Well, you could write a number here, like 4, 5, whatever. But since NESmaker already has provided us with a variable called myMaxHealth, I just used that variable. So, for example, you saw when I picked up the big heart, the max health increased from 3 to 4. That's the sort of thing you can do if you're using a variable instead of just writing 3 as max health. Alright, so then we have a filled health container. That's sprite 125. So that's this one. And what's the current health? What's the health right now? Well, of course, we have a variable for that in NESmaker. It's called myHealth. That's going to keep track of the current health right now. And finally, this last one, that's for the attribute for the sprite. Now the attribute, it can do several things, but if you're just starting to learn this stuff, then you can think about this as the what color to use, or what palette, what sprite palette to use. So basically, you can think of it this way. We have palette 0, palette 1, palette 2, and palette 3. Oops. Yeah. Palette 1, 2, 3, 0, 1, 2, 3. So that's how screens are set up, right? When you go to screen info, day monsters, you set up these different subpalettes for the sprites. So here in when we're using this draw sprite HUD macro, if we write only zeros, then it's going to use the first one, this sprite palette. That's sprite palette 0. If we write a 1 in there, it's going to use the next one. It's palette 1. Since this is binary, we need to remember that that is sprite palette 0, 1, 2. This is sprite palette 2. If I wanted to use the last one, sprite palette 3, then I would have to write 1, 1 in there, because we're using binary. Now, of course, I could have written something else. I could have written 0, 0 or 1 or 2 in there. But because attributes are more than just colors, it's probably a good idea to just get used to writing these in binary, because later on, when you want to do some more advanced things, these bits can be used to flip sprites vertically, horizontally, whatever. So just get used to writing these attributes in binary. Alright, anyway, that's how we draw this life bar. Lives, I just used the macro called draw sprite. Now draw sprite, that's just gonna draw a sprite. It's not gonna be a health bar, anything like that. So first for the lives, I just want to draw, let's see, I just want to draw this sprite as a sort of a label for lives. Then I'm going to draw another sprite right next to it, but this time I'm not drawing a sprite drawing. Here, sprite 105, that's this little face. Then right next to this sprite I draw another sprite, but here I'm not specifying what sprite graphic to use. Instead, I'm using the variable myLives. The variable myLives can be 0, 1, 2, 3, 4, and so on. So that's going to draw either this sprite, this sprite, this sprite, this sprite, and so on. That's why I always like to have numbers from 0 to 9 here at the very beginning of my game object tile graphics, because it makes it so simple to use numbers as sprites. Yeah. So this is sprite 0, this is sprite 1, and so on. So here I'm actually using a sprite to display the number of lives. And I do the same thing with ammo, keys, and actually currency as well. Although currency is a little more complicated because we have several variables there. Alright, I think that's enough about the Sprite HUD. Then we have another important thing here. So in our modified game, let's go back to script settings. And let's look at the pickup script here. So here in the pickup script, this is of course where we can basically do whatever we want. If we want the player to pick up something. Now obviously, if we're making a pickup object, like for example this key, we have to make sure that it's set up as a pickup object here in object details. We have to make sure that this is set up as a pickup object. So when the player collides with this object, then the pickup script is run. Then we check based on object type. Is this object 3? Is it 4? Is it 5? Is it 6? And so on. So in other words, is this object number 0, 1, 2, 3, 4, 5, 6. So we're checking what object we're colliding with. So let's say we collide with object number 4, which happens to be the health pickup. Here I just add a little code to increase my health. Same thing for ammo, I just increase my ammo and I check, do I have maximum ammo? If I do, then I don't need any more ammo, and so on. So pickup script, it's pretty simple. You just check what object you're colliding with and you do something with that. Yeah, I don't think we need to discuss anymore. Actually, let's just do one more thing here. When it comes to this currency pickup, because here I'm using the macro called add value. Now add value is a little confusing to some people, but it's because you have to give all of these different arguments. Now in my game I have 3 digits for my currency. So it's displayed in the sprite HUD, 3 digits. That's how much money I can have. Now in NESmaker, to do that we need to use more than one variable. So here I have my money 100, my money 010, my money 001. each of these variables keeps track of 1 byte, of course. So if we have the number 100, for example, then we would have a 1, the number 1 in one of these, and 0 and 0. And that's what's going to be displayed in my Sprite Hud. So, but luckily in NESmaker, these macros are pretty well documented. It says what the different arguments are. So you should be able to figure that out. And if you don't, you can always use the NESmaker forum to ask for help. Alright, now I think we are done with the pickup script. So we have looked at hurt player, hurt monster, but what about if we wanted to add a new tile, for example? Let's look at the tile I made, that locked door tile. So I'm going to go to project settings, script settings, and go down to the tile. Let's see if I can find it here. Locked door, tile number 6. Now you usually just assign. You make a new assembly file, .asm file, and you just assign it here in a normal way, right? But in some cases, especially if you're using if you're replacing a tile, for example, trampoline or whatever, or solid tile, especially if you're replacing solid tile, there might be places in the NESmaker code where you need to modify, especially in the handle physics script, because there are hard-coded places in the physics script that reference this specific file, the specific tiles. But anyway, here I have the locked door that I made. So as I assigned that to tile 6. In addition to assigning that to tile 6, I went here to project labels, tile types, and for tile 6, I just wrote a label that made sense, locked door. So when I go to my map here, I can go to collision and choose locked door. Instead of it just saying tile 6, now it says locked door. So now I can make sure that if I want to place a locked door tile here, it actually says locked door. And let's also just quickly take a look at how I made that tile. So basically what this does, it checks it checks the variable my keys. Do I have keys or not? If I do have keys, I change the tile. I use the macro change tile at collision, so the tile is changed to collision 0 or graphic number 0 and collision 0. So graphic 0, that's always going to be the top left tile here. So in this case, top left, that's just a dark blue tile, so this is going to change into that when I collide with that tile. If I have keys. If I don't have keys, then I jump to door is locked, and then it just acts like a solid tile. Alright, I just wanted to quickly show you how you could make something like that. Yeah, also another very common thing is to see if I can find my mouse pointer. There it is. So what if we wanted to do some custom thing, make a custom AI? Because by default in the Metrovania module, you don't have a lot of let's go back to stock NESmaker. So this is stock NESmaker. Let's look at the different let's go to a monster here. If I go to the wizard monster, then I go to object details, and then I go to actions. Now let's see what kind of actions we can set this monster up to perform. So we have move left, we have stop moving, and there's one called move random. So we don't have a lot of different actions by default that our monsters can perform. Basically, we just have move left and stop moving. So if we go back to the modified NESmaker now, and let's go to a monster again. Actions. So I've added one more here. It's called bounce. So the way I did that was to I went to project settings, script settings. I went all the way down to let's see here, it says AI behaviors. I made a new assembly file, .asm file. I just called it bounce.asm, and I just made sure to put it somewhere that made sense. Game engine data routines base 4.5 game and mod Metroidvania AI. I just put my bounce.asm file in there. Then I assigned it to a free AI type. In this case, AI type 4. And again, just to make sure that we're doing things tidy, went to project labels, action types, and I gave it a name that made sense, bounce. So that when I go here to this guy, go to actions, I can actually select bounce if I want. And if you're wondering what that code looks like, it's just this. I just copied a few lines from the player jump script, the input script, and I just put it here in an AI action. So it's pretty simple, but to find it, script settings, AI behaviors, and just assign it to a free AI type. If you go a little below that, you can see that then we have these edge reactions and solid reactions. Those are, of course, for when we go to details. Solid reactions, edge reactions. So if you want to add some new ones there, then you know where to find it. Right here. Edge reactions, solid reactions. Okay, so now there's one thing that is very hidden in NESmaker. If you don't know where it is, or if you don't know someone who can tell you, then it's very hard to find. It's something called timer end script. Basically what that is, if I go to object details here, go to actions. Here it says move left, so this guy is going to move left. But end action, advance, repeat, go to first, go to last, whatever, destroy me, go to warp. Can we modify these? Yes, we can. But then we have to go to this mysterious script. In fact, here you can see here at the bottom, there are two free end action slots. So we can even add two more in addition to the ones that are already there. But where can we find this mysterious script? Well, we have to go to a NESmaker folder, game engine data, routines, base 4.5, game, and subroutines. Here in subroutines we have a lot of different subroutine files, but if we go to the bottom, almost to the bottom, there's one here called timer end scripts. This is where we can modify or add something to what happens after an action is done. So for example here, the first one is advance, so advance to the next action step. Then we have repeat an action step, and then we have go to the first action step, and so on. Go to last, go to previous, destroy me, go to warp, and so on. Go to continue. And if you scroll down here we have two free slots. So if you want to add some custom thing where at the end of the action, if your player or if your monster moves left, at the end of that action you want him to explode or whatever, then you can add some custom action in here. And like always, if you do that, I recommend going to project settings, project labels, and going to let's see here, end actions or end animations, and you actually call that, for example, explode. Now these two are actually the same, end actions and end animations, so you actually have to write the same thing twice. So explode. So if you made something here in timer end script, some explode code, then you can go to your monster here, object details, action, move left, end of action, explode. But of course you would have to write some decent code for that in here in the timer end script. Okay, so hopefully you can see that here in script settings, basically this is where you find all the really important things, except for the one we just looked at, timer end script. So we don't find everything here in script settings, but there is a lot in here. There's a lot that will help us. All right, well, I think that's enough. So I hope that with all of these videos, learning assembly language, and finally with this video, that you hopefully you feel now that you're comfortable modifying or adding new features to your NESmaker project. Now I will create more videos, and also going forward now I might create more advanced videos, because I'm going to assume that you at least have watched a few of the assembly course videos. So probably we're going to be looking at more advanced projects going forward. I just want to end this video today by showing you an example of a game that we're going to be looking at next time. This is the game we will be looking at next time. This game called Alien Invasion. Now the special thing here is that we can select our player. You can select whatever player we want from these 8 player characters. And if I do that, of course, the player will have his own abilities. So that's the game we will be looking at next time. But like I said, I hope you enjoyed this assembly course, and I hope you have a great day. I'll see you in the next video. Bye bye.